you might say. I really think that there was the mentoring, and that was how we got in touch with the Coffeyville Refinery and how we got insight into the market. But then there was also, there was this talk of how this could benefit Ventura, and I really think those things can be separate but equal and important. I don't know how the rest of my team feels about that. But.
Yeah, I mean, it made it a little more complicated sometimes because you are getting mentored by someone who you're also selling the technology to or trying to sell the technology. So it made it a little more complicated, but also made it even more real-world experience, like you're going to have to be dealing with all those complications.
Driving up an hour to Oklahoma City to their offices, and a lot of getting up at 7, fitting in their schedule, and but then also having them come down here sometimes, and it really, I think it worked real well.
What are the environmental effects of this technology?
It's not going to have any environmental effects. It shouldn't.
No change in
No. Well, although increased energy savings would conceivably lower, I would say there's
the one thing that I guess it could do is increase capacity of the units that handle the lighter products, like reformers and stuff like that, and it might increase the capacity or the amount of product going to those units. So if that increases, I don't know if that's going to change the emissions of those units or not. But
why did you have to do the experimentation yourself? I thought that was part of the inventor job to do that.
Well, that is one of the our inventor had a graduate student work on this. I'm not sure when, a couple years ago or something. But they weren't really pleased with the results that the graduate student produced.
And Dr. Bagahewicz is very busy. This is not his only invention, nor his only responsibility. So I think it was a unique opportunity for Andy, a chemical engineer, and me, a physicist, to get an insight into chemical engineering experimentation. I think actually the experimentation was maybe almost we kind of wanted to do it to really get our hands on with the technology, see the results, get our hands dirty and smelly with some crude oil, and so I enjoyed it.
The quality of crude oil can actually vary significantly from one batch to another batch. How did you take into account that in your calculations and projections?
With simulations, we you can vary the quality of the crude oil, what type of crude oil, the weight. As for the experimentation was more of a proof of concept. We took McLean County crude, which is has an average weight, what is it, API gravity, I think is
a pretty light crude oil.
But the type of crude oil that is used does have an effect on how this technology, how much revenue this technology can add. But the proof of concept is that this should work for all crude oils.
I guess another way to ask this question is, where do you get the greatest benefit? What variety of crude oil, or do you know?
Dr. Bagahewicz has run those simulations. We don't have a simulation that, like any of us interns built with and without the technology, but Dr. Bagahewicz has those, and I know he has processed the different types of crude oil in his simulations. And if I remember right, he said that heavier crudes tend to produce better results, probably because the heavier crudes are going to produce more residuals than light crudes.
Which actually provides an interesting business opportunity, as seeing that a lot of U.S. refineries are moving to heavier crudes from Canadian tar shale. So that's an interesting sort of future market analysis that really could be done.
Got one more question?
Refineries opening up in Oklahoma again after closing and closing and closing. The refinery is very small.
Yeah, it is.
One, how do your results vary with the scale of the refinery in terms of the profitability? And two, I noticed that you didn't have any heavy oil products. You started with gas, and you didn't have any heavy products there. Does that have an impact? Because most refineries will move to heavy products during the summer months and then the lighter products during the winter months.
The second question, the gas oil being at the bottom, that is sort of an artifact of us working with the Thomas Refinery, and that is their residue product. As for the scale, I'll let Andy.
What was the first question?
The scale.
The overall scale of a refinery shouldn't affect the technology's usefulness. It may make the capital cost, or will make the capital cost higher because of the size of the equipment that you'll need will all be scaled up. But then when you compare it to its effectiveness, it's going to have roughly the same effect. So, I mean, a lot of the huge refineries are running multiple process flows, and so I don't know what kind of the maximum flow rate you can have through a single process flow. It's probably 150, maybe 200,000 barrels, and after that, they're getting their extra capacity from just laying down the same thing twice, so two or three process flows.
The profit and the capital cost for this technology should correlate somewhat linearly to the capacity of the crude unit. If it's larger, the capital cost can be a little bit more, but you're also going to get a much larger profit because you're going to be able to decrease the residuals even more. So that answers the question.
Can I ask one other question? What you learned about implementing this if you're going to design a new refinery, maybe I'll target this at you, or if we just got a jillion existing refineries all across our country and want this OU technology brought into there, well, what's the best timing? Is there a good time? Is there a bad time? How do you sell that?
Well, we've actually been talking about the best time, and this is for Thomas, but it would apply to any refinery, is any sort of downtime when they're doing maintenance or something like that to go in and implement. Of course, you'd have a lot of preparation before that, figuring out where, physically things would be attached to one another. But as far as maintenance downtime, that happens every year.
Depends on the refinery. It's 2 through 3 years.
It's a regular cycle.
So for a 120,000 barrel refinery, how long does it take to put this little dude in?
It really only has one tap-in in the main distillation column. That would be the complicated part. And other than that, there's another
possible.
Yeah.
Less the man hours. I think Dr. Baggett-Hewis has said that this might add 2 to 3 days to the traditional downtime of about 2 weeks to a refinery. So if you can get all that engineering work done beforehand, it really can reduce the opportunity cost of putting this technology in.
And in a year on 120,000 barrels, then you're going to make another $18.
Yes.
Okay.
Fantastic. Thank you.
So as you can see, this team is emblematic of the range of work content that our interns get to participate in. Everything from the first group, which was more of a later stage opportunity where a company was actually spun out of the university and we're trying to help formulate go-forward business strategy, to more even technical validation at the very early stages of the idea, moving into how do we get this to market. So I think it's a great breadth of perspectives and experiences that our interns are getting to